Hello everyone. I hope you are doing the homeworks I have given. So the next topic, theorem 1.6. It states that a rational number p by q will have a terminating expansion that's only if the q is in the form of 2 to the power n or into 5 to the power m. So x will be terminating rational number only if q, where x is a rational number that can be written as p by q. So q is in the form of 2 to the power n into 5 to the power m. So before we learn further, let me revise one part, that is real numbers are of two types, that is rational and irrational, right? And rational number are of two types, one is terminating, other is non-terminating. Irrational number is always non-terminating and non-repeating, and rational number, if it is non-terminating, it should be repeating. You have done this in class 9th. We have proved this kind of number in the form of p by q. So a number which can be written in the form of p by q will be rational, right? So this is rational and this part is irrational. So this theorem surrounds this part, and it states that rational number will be terminating only if out of p by q, q is in the form of 2 to the power n and 5 to the power m, where n and m can be equal or different. Here n and m are non-negative integers, okay? So now let us start the exercise number 1.4, question number 1. So in this question we need to check whether this is a terminating or non-terminating expansion. Simply finding the prime factors of 3, 1, 2, 5, we get this. So we can state that it is a terminating rational number. Let's do one more question. So here q have 2 and 5, of course, but it also have another number which is different from 2 and 5. So the theorem says that it should only have 2 or 5 or both, nothing else, okay? So since it has 7 as its factors, therefore it will be non-terminating rational number, and non-terminating rational number means non-terminating repeating, okay? So in the next question, always remember p by q, this is p, this is q, right? And p and q should be co-prime. So we can see that 7 is common in both of them, so we have to cancel 7, and then we can state that whether the number is non-terminating or terminating based on the factors of q. We will see the factors of q only after cancelling all the common factors, because p and q should be co-prime, right? Remember what is co-prime? So again it have 2 and it has 2 and 5, but also it has 3 extra, so it will be non-terminating. Let me clear one concept here, like this number 35 and 70, okay? So we have to calculate we cannot just say that this is 7, 2 and 5. We have to see what is up there. So we have to find the factors of this number also, and then we can see that these things are cancelling out. So now the answer is half, okay? So obviously it is terminating. So always remember, we have to calculate the factors of both the numbers if something is common. Like here we know that there is no 2 or no 5 or no 7 in this, so we have not calculated the factors of p. Rather, we know we can just answer by seeing the factor of q only, but here we have to calculate it. So regarding this, there is a concept to understand, and some questions are there on that concept, that how can we determine the number of digits after decimal? How can we determine that how many numbers should come after the decimal? There is a theory of that. So if we have a rational number where q is in the form of this, then we know that this number is terminating, but when it will terminate, that will decide this n and m, okay? See, 3 by 2 cube, so here n is equal to 3, so there are three numbers after the decimal, and you can clearly see that 2 to the power n and 5 to the power n is 3 and n is 1, right? So the highest out of n and m, okay, that will decide that how many numbers are there after the decimal. So highest is 3, so 3 numbers after the decimal. You can see some more example. The highest will decide how many numbers after the decimal, right? Now another similar example, but this time the highest power is 4. So how many numbers should be after the decimal? There is 4, right? You can calculate this and see that there are 4 numbers after the decimal. You can see as many examples as you have, okay? 4, so 4, this is 5, so 5, okay? Now question number 2 of last exercise. In this question, you just have to divide the question parts of the question number 1. So simply divide all the parts and write it like this, and you can check the above concept here also. How many numbers are there after the decimal? You can check by the powers of the given questions, okay? And the last question of the chapter is, we need to say about the prime factors of Q. So the first part is terminating, so prime factors will be 2 and 5, and second part is non-terminating, non-repeating. So of course it is not a rational number first of all, so it cannot be written in the form of P by Q, so there is no question of prime factors of Q, right? And the third part is non-terminating repeating one, so the Q will have other factors than 2 and 5 alone. Okay, that's all we have to write here.